Hi, welcome back. This is week 1, video number 1. In this video I'm going to start going through the PowerPoints and for chapter 2 in the Shmueli book. And I'm assuming that you've read the material already one time, and this will be a second exposure to the material, and then when you go back to do the homework, it'll be a third exposure. And you need at least 3 times seeing material before it starts to sink in and you start to get it. I am going to go through this fairly quick though, however, since you have read the book already, and I'm going to hit the highlights and not go through every single detail. There's several core ideas in data mining, and we'll talk briefly about these. The first one is classification. Say someone comes to us to get a loan, we're at a bank, and we have to classify them as to whether we think they're going to default on the loan or not. Last thing we want to do is get someone that's going to default and cost the company, the bank, more money. There's prediction. We want to get an idea of how much a customer is going to spend with us in the next year, and are they going to spend a lot? Are they going to spend a little? That's a question that can be answered with data. So with prediction, we are trying to predict a numerical value inside of some sort of range, and that's where this is different from classification. Association rules tell us how things are related to each other. For example, how chips and salsa, are they related to each other in terms of cells? Is milk related to salsa? So the association rules tell us what the relationships are, but also tells us how strong the relationships are. Data reduction refers to taking a very large data set with thousands or tens of thousands of variables and stripping out the essential information by reducing that down to a few variables. And the different techniques that we'll talk about are some are better than others at using large numbers of variables, and so that's something that we will talk about in detail. Then there's data exploration, where we look at histograms, scatter plots, measure correlations, measure sometimes three-way interactions, and try to understand the individual variables that we might be interested in, see how those fall into the mix. And then when we get to chapter 3 in Shmueli, we'll see just exactly how complex visualization can be, which is even more a further extension of data exploration. In data mining, we have 2 types of learning: supervised learning and unsupervised learning. And supervised learning is when we have a target or outcome variable that we want to predict. We'll build our model on training data, and based on that, we'll be able to then, when a new customer walks in the door, we'll be able to take their information and generate a score for them, let us know how that customer should fare compared to everybody else that's been in our system. So we build our model on our training data, and then we use that model on our new customer when they walk in to determine whether we want to give them a loan or whatever it is that we're interested in determining. And the methods that we use to do this supervised learning are called classification and prediction. In unsupervised learning, there is no target variable. All we're trying to do with unsupervised learning is to group the data into meaningful segments and detect patterns. So if we have some demographic data, for example, on our customers, we might want to apply some of these unsupervised learning methods to determine what types of customers we have, see if there's any natural groupings. For example, do we have any Dean couples where we have dual income, no kids, so lots of money and no kids to spend it on. Or do we have lots of families, the opposite, lots of kids and no money to spend them on? So again, there's no target variable here. We just have association rules, data reduction, exploration, visualization, which we try to see if there's any groupings, natural groupings. For supervised learning and classification, we have a categorical target variable that we're trying to predict, such as will somebody default on a loan? Is a long distance phone call going to result in a sale to a customer? So typically in our data set, each row is a case, a customer, tax return applicant. Each column represents a variable, and the target variable is generally binary: yes, no, on, off, success, failure. For prediction, using supervised methods, the goal is to predict a numerical target or an actual number. For example, sales, revenue, performance, these are all measures that come in a range. So sales, do we want to predict sales for next year? Is it going to be between $3 million and $3.5 million? There's a whole range there. It could be anything between those numbers. Just like with the classification, each row is a case, each column is a variable, and taken together, classification and prediction constitute what's known as predictive analytics. Sometimes you might see this also described as business analytics or predictive analytics. For unsupervised learning, we have association rules where we have a goal is to try and understand what goes with what. For example, if X was purchased, Y was also purchased. So a very good example of this is if you go on Amazon or use any of these music or movie recommendation websites, they look at things that you've purchased or watched or listened to, compare that to what other people have also purchased and watched and listened to, and look to see if there's a relationship, and then they make recommendations. If you liked a particular type of music and this other guy liked this particular type of music, they'll make recommendations to you that to try something new. Of course, they know what you've already looked at and haven't looked at least on their website. This is called affinity analysis. With unsupervised learning, we have what we call data reduction, and this is simply the distillation of very large data sets into smaller, simpler data sets. For example, you could take 100 variables and extract the information contained therein and be left with just 3 or 4 variables. Reducing the number of variables is generally done by principal components. There are other ways to do it as well. There are other methods that we'll talk about, including clustering, for doing this as well. We also have data visualization, which is graphs and plots of the data, but it's actually a lot more than that as well. As we'll see in Chapter 3 of Shmueli, there's a whole kind of different in-depth field where people do this in their software, and in fact a lot of it's stuff that's not covered in your typical statistics courses. And then there's data exploration, and typically with large, complex, messy data sets, there's quite a bit of work that needs to be done in order to review and help refine the task that you're interested in solving and doing. And when you have data miners that spend a lot of time working on this stuff, that's actually a good thing. instead of, I mean, you might wonder why they're spending all their time exploring the data, but that's actually a very big part of data mining, very important. And the other half of their time is going to be spent refining the models and extracting the information contained therein. Okay, so this is the end of this video. I'm going to pick up where this leaves off in the next video. I'm trying to keep these to a reasonable, manageable length.